All right, so now that we've talked about what is a box plot and what all the parts are, we're actually going to go ahead and create one. But before we do that, I want to call attention to something that I didn't mention earlier, so I've gone ahead and highlighted it, which is that a box plot must be drawn above a number line. And the reasoning for that is we talked about how the length of the whisker or the length of the box actually has a value. It's telling us how spread out the data is. So in order to make sure that we're accurately representing how far apart our data is, we go ahead and we put it on top of the number line. Now, number lines are not just lines with numbers randomly marked on them. So something like this, 2, 5, 10, those are not equally spaced numbers. So that would not make sense. A number line does have to have each of your numbers equally spaced from each other. Once again, the length must actually represent something. So here, each of these represents 10 extra minutes on the travel time. So we want to make sure we're actually doing it in a number line. One of the things we're going to do as we make one is we're actually going to use some technology. And often when you make a box plot on technology, they will create the number line for you, or even sometimes they might just put it on a coordinate plane, in which case the x-axis would be your number line. So let's go ahead and look at this. So here's our example. It's talking about Barry Bonds and his major league records with his home runs. So beneath it, it gave us all of the data for how many home runs he had in each of his seasons playing. So that's what this data represents right here, 21 seasons, how many home runs per season. And we want to put this in a box plot similar to the one above. Now, what we saw above was that in order to find each of these pieces, we actually want our numbers listed from lowest to highest. We can find the minimum, the quartile 1, the median, the quartile 2, and the maximum ourselves by doing that, but we can also use technology. Technology is wonderful, and it does a lot of this for us. So what I'm about to show you, you can do on a TI-84, and a lot of people will, especially if you're taking upper level stats class. That might be the calculator that you have access to. But also, a lot of classes are integrating Desmos more. It's a little bit more user-friendly for a lot of people, and so I'm actually going to show you how to do this using Desmos. So I'm going to go ahead and pull that up. So I want you guys to notice the very first thing I did is I already put my data in. As a reminder, I'm going to come down here to one of these random ones. In order to put in a table, there's this plus sign in the top left-hand side. I can't really show you guys here, but if you look in the top left-hand side, you see the plus. I'm going to click it. You guys notice where I clicked, and now it says table. So I can just type in a table and then type in all the data I want. Now, I don't want this one. I've already typed it in for the sake of time. Those are the 21 seasons. In an earlier video, I showed you guys how to find the mean and the standard deviation using Desmos. I went over here. Once again, if you see that I've got pulled up the keyboard that actually goes with the Desmos, if you are on a browser and not the app, this is, if there's a little like keyboard icon at the bottom, you can go ahead and click that. It'll pull up the same keyboard that I have here. And in the very right, there's this functions button. Now, because we're doing statistical analysis, we want to look in these stats. So on my notes that go with the box plot, I have you guys find the mean and the standard deviation, just because that's good practice whenever you're doing any type of statistical analysis on a set of numbers, just trying to understand where the numbers are. The mean and the standard deviation is great. We saw what that looked like with the empirical rule and using normal curves. However, for a box plot, we're going to need a little bit of different information. So the first thing I'm going to do is I'm going to make sure, I'm going to get rid of this. Make sure I'm in a new box. So box 1 is actually my table. 2, give me my mean. 3, give me my standard deviation. I'm going to click in box 4, so I'm ready to do another function. Now my goal is to find the 5-number summary that I need for my box plot. So I'm going to go over in functions. You might read through these and be like, I have no idea. Oh, I can do the min. You might get stuck in this quartile. Maybe that's it. It's actually really a lot easier than that. Towards the bottom of this list, all the way to the right-hand side, notice that it stops on stats. That's actually the one that we want. Now, I have to tell it which data is it running it on. Once when I come up here, I notice that my data is in the X1 column. So I just say run this on the X1 data. I'm going to show you guys how to type that in. So I'm obviously hit X. To get the subscript 1, I'm going to hit the ABC button. And right here next to the 1, 2, 3, there's this A with a little B. That gives me my subscript. So I'm going to go back to 1, 2, put it in. I can close the parentheses if I want, but notice, bam, there it went ahead and gave me all of the numbers that I need for my 5-number summary. So I have my minimum, my quartile 1, my median, my quartile 2, and my maximum. So at this point, I'm going to go and actually add all of these numbers to my notes so that we can go ahead and use them. So I'm going to come over here. The mean we said was about 36. The standard deviation was 12.7. So there is a decent spread amongst this data. But what I really, really want is for my 5-number summary for this box plot. So my lowest number is 16. That was his lowest homeschooling year. And his highest is 73, a year with 73 ones. The median was 34. And because this is an odd amount of number, my quartiles are actually going to be kind of averages here between two numbers. My quartile 1 was 25.5. My quartile 2 was 43. So once again, I just got those numbers on the other page. Now, before I can actually come down here to create my box plot, I actually have to determine, do I have any outliers? Because that's going to determine where my whisker goes. So let's look at that first. We said in order to find our IQR, we're going to subtract our quartiles. So 43 minus 25.5. Sorry, that should be 45. I just looked at that. Let me make that quick edit. All right, so now I'm actually ready to find it, and that gives me 19.5. So once again, this would actually be the length of my box. But in order to actually find my boundaries, I actually have to do this times 1.5. Is that 1.5 IQR? So I'm going to take 19.5, and I'm going to multiply it by 1.5, and that gives me 29.25. So I know that this is the longest that my whiskers can be. So I'm going to start with my Q1. I'm going to do 45 plus this number. I said Q1, this is my Q3, pardon. So I'm going to do my higher end. I'm going to do 45 plus my 1.5 IQR, and this gives me 74.25. Well, my maximum number is 73, so we're good to go. I'm not going to have anything that is larger than 74.25 because my maximum number is 73. I'm now going to do the bottom edge, my lower edge. So I'm going to take my Q1, 25.5. I'm going to subtract this number, 29.25. Immediately, I can see that I'm going to have a negative number because I'm subtracting something that is larger, but the exact number is negative 3.75. Obviously, we can't have negative home runs. So once again, I'm going to give it a check mark. There are no outliers in this data. And so that is important because some people look at this and they're like, oh my gosh, 73 is so much bigger than everything else. That's got to be an outlier. This is how we actually determine it. You find your IQR, you subtract these numbers, multiply by 1.5, and then add that on to see the length, the longest your whiskers can be. If you have a number that is longer than that, then you know you have an outlier. So here, my answer to this, are there any? No. All right, and now we're actually ready to make our box plot. So once again, the very, very first thing I'm going to do is I have to draw this number line. Now, my numbers have to go from at least, let's say 10, because my lowest one is 16, up to, I have one at 74 or 73, so let's say 80. Now, these need to be split the same kind of distance along. I'm going to try my best to do this. If you had a ruler, you could really mark it out. I'm going to do 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. So I did my best to make these the same lengths. You say, notice that they may not be perfect, but they are approximately all spaced the same, and they went up by the same increment each time. That's what we mean by a number line. Now I'm ready to put my numbers on here. So my minimum was a 16. So my minimum is just ever so slightly on the other side of 15. So I'm going to make that pink. My maximum is 73, so it's going to be between 70 and 75. And if you want, you can actually label those because when you're on a number line like this, sometimes it's harder to see. I'm going to go ahead and do my median as well. My median was 34. And remember, that's going to be a vertical line. This is that line on your box. And now I can do my quartiles. My first one was 25.5. And my second one was 45. Now I can just actually draw in my box and whiskers. So remember, between my quartiles is going to be my box. And then I draw from my box out to these points for my whiskers. And there you have it. We have created a box plot for this data. And we can see this is our largest. So the data in the top 25% is more spread out. There's a lot of spread between it. 45 to 73, that's a pretty large range, versus the bottom 25% is all pretty close together. There's 25% of the data between 16 and 25.5. So that's really kind of what our data is telling us. It also kind of looks like our middle 50% is pretty equally distributed on either side. And this could even be one of those things again where we know we can't have negative, so there's not a lot of space between 16 and 0, but you could actually have as many home runs as possible. So this number could technically even be larger. So there's even more ways to spread out this top side. So that is making a box plot.